15 to 20 range of you have done your problems properly. You have taken from the question paper, and even some of you have mentioned from which question paper you have taken. So everything is there. Okay. Still, you have to work on it. Okay. So last class we were solving the problem on the Worm's gap, where the center distance was known. So center distance was clearly specified in the problem, but in this particular example, which we are dealing in today's class, the center distance is unknown. That means the center distance would not be given. Trust me, there is no huge difference in the procedure what we follow, except there is a formula addition to the normal procedure what we have followed in the last class. Just there is a one extra formula through which you can calculate your center distance. That's it. Everything else is again a ditto copy of the previous problem. So I make sure, all of you make sure that you solve along with me. Everyone should participate so that we would complete this problem. So as soon as we complete this problem, we will leave the class. I am assuring about that. Okay. So we shall complete this problem and finish our class today. Is that fine? Shall we start? Everyone ready with your data handbooks and calculators? Okay. Let's start. And how many of you are referring the YouTube videos which have been posted in all the platforms are posted? I mean, given in WhatsApp also, even in the Google Classroom also. Okay. So do check that, and whatever you answers will give. I was just recapping those videos. I was seeing my own videos in the YouTube. How does it reflect on the screen? I felt very happy that it reflects very good with a good sound quality. With whatever we have explained here, the same would be reflected over there. Pretty much happy, and even your answers also, it would be portrayed on the screen. Suppose if, say, for example, Arif answers something, so his photo would be coming on the video picture. So that is what I have liked. So once in a while, if I go through, you can get to know your participation levels also. So make sure you participate in a good, dense pattern. Okay. We shall start this particular problem. Design a worm drive for a speed reducer. To transmit the power of 30 kilowatts. So given data, first major thing what he has given is the power, which is 30 kilowatts of power. Very good. At a worm speed of, so initially you just draw a worm, which is like something like this, and a worm wheel, right? So this is worm, and this is worm wheel or a worm gear, whatever you can call it as, same as the previous problem. Okay, the worm speed is how much? 600 RPM is the worm speed. That is N1. So N1 is how much? 600 RPM. You can even have the value of N1 in the RPS also. So just divide it by 60 so that you will get it in RPS. Keep this value up. It would be easy for us to substitute in the further coming problem. Okay. Next, the velocity ratio is the required velocity ratio. So I dash he has specified. First of all, what is I dash? It is either N1 by N2, or it is capital N1 by N2, or it is D2 by D1, or it is Z2 by Z1. Any one of these could be the value of I dash. So from this, first calculate the value of N1 in RPS, and then give me the value of N2 in RPS. So what would be N2? So 25 is the speed reduction ratio what he has specified. So I dash value he has given it as 25. So from this, what I can imply? So 25 is equal to 10 divided by N2. So from this, N2 is how much? This is 10, I guess, right? In RPS, 600 divided by 60 is 10. So from this, what is N2? 0.5. Not 25 divided by 10, 10 divided by 25, sorry. So it's 0.4. It's 0.4. Shall we go up with the solution? Yes. Shall we start the solution? Anything else is given? Let us see. The worm is made up of C40 heat-treated steel. So worm gear material he has specified as C30. Sorry, C30 heat-treated steel. Okay, and the worm wheel is made up of phosphorus bronze. So worm wheel is made up of phosphorus. This phosphorus bronze for the worm wheel is pretty common. So it is better to assume this particular material if he is not given also. Okay, so here it is clearly specified that worm is made up of C30 heat-treated steel and worm wheel is made up of phosphorus bronze. Very good. The service conditions are intermittent operation. Very good. So he has specified to take the value of CS, that is service conditions. He has specified. What are the service conditions? Intermittent operations in the sense it is not continuous. Whenever we require, we operate this particular gear, intermittent in operation. Very good. And the medium shock. So medium shock load. Loading pattern is also given. It is not heavy, not light. It is but medium. So medium shock load has been given. Also calculate the heat dissipation through the drive. So design in the sense whenever he uses the word design, I tell you, calculate each and every component starting from your module. Next, calculate your dynamic load. Next, calculate your wear load. Next, calculate your efficiency. Next, calculate heat generated and heat dissipated. So everything has to be done, irrespective whether he has asked or not. Okay. So when this has to be done? When it is specified to design something. So when he specifies, when he uses a word design, you are supposed to do all this. Okay. And this particular problem will be not asked less than 20 marks. It would be a 20 marks question for you straight away. So you can happily solve the whole problem in 20 minutes. Okay. So 20 minutes, 20 marks you will get. Shall we start the solution? Ready? Okay. So the first thing, he has specified the materials, isn't it? He has specified the materials, but he has not given the value of sigma D1 and sigma D2, which is very much essential for us, isn't it? The values of sigma D1 and sigma D2 has to be taken out from the table. So you just pick that particular values from the table number 12.7, the page number 234. Go for the certain material over there and given the value of sigma D1 and sigma D2 from the table. 12.7, page number 234. Yes. Refer your data handbooks, everyone. Give me the values of design stress for the material which he has specified using the table 12.7, page number 234. Okay, so 220.6 is for worm, Dhanush. So I'm taking it as respectively 220.6 and 82.4. All of you got the values? The same values from your data handbook? If yes, raise your hands. Good. So once you've got the material specifications from the table, so now it is time to identify the weaker part. So generally in a worm and a worm whale, what you are going to identify as a weaker part and why? Anyone? Which, whether it is worm or it is worm whale, that you identify as a weaker part? Yes, so always you identify the weaker part to be a worm wheel. Worm wheel always. So just write the sentence, the worm gear or a worm whale. All the things are the same. Worm gear or worm wheel is assumed to be a weaker than the worm. Just put a comma there. Okay. Since it is subjected to sliding action, always it would be rubbing on the worm wheel. So the teeth would be breaking very soon on the worm wheel, not on the worm. So thereby resulting in overheating and leading to failure. Just write the sentence. So could you identify what is the major difference between the previous problem and this particular problem? Major difference, which I have highlighted in the top of the question also. What is that major difference? What is that major difference between the previous problem and this particular problem which we are solving today? Center distance, isn't it? So the center distance was not specified in the previous problem. So was specified in the previous problem, but this particular problem, it is not specified. So it's our preliminary duty to calculate the value of center distance. Now, all of you just look into your data handbook. Do I get something through which I can calculate my center distance? Look for an expression. Not necessarily it might be A is equal to something, but wherever it might be, suppose something like power is equal to something of something A and something like this. Okay, so that I know the value of power. Through power, I can calculate the value of A. Look for that particular expression in your data handbook and let me know. So look for the expressions in the data handbook through which I can calculate my center distance based on the power given. So power is 30 kilowatt. So based on that power given, based on the power that need to be transmitted, I have to calculate my center distance. Is there any formula that would facilitate this? Please check your data handbook and let me know. Is there any formula through which I can calculate the value of A by substituting the value of the power? 228, whether it is equation number or a page number? Page number 228. Okay, so where is that equation?
12.68.
12.68. Okay, yes, 12.68. Here is your expression. You can see here. This is what I was talking about. So in this particular expression, if I substitute the value of power, which is given, okay, I have the value of I dash, which is given. Okay, so the only unknown would be the value of A, through which I can calculate my center distance. Pick this particular equation number 12.68a in the page number 228 to calculate your value of A. Okay, so pick that particular equation there. Okay, substitute the value of the power, which is 30 kilowatts, and the value of I dash, which is 25, and let me know the value of A. So you can use the calculator method. I told you in the class also, even now I have told you multiple times and while teaching you VTD, you can use directly. So 30 alpha is equal to this one 0.02905 into alpha x to the power of 1.7. Next in the denominator you have 30. So shift to solve. Is this value correct? Correct. So it is 438. So use always this particular procedure. It would be easy using your calculator. Okay. Now the value which you have given me is 438.35. See, 438.35 cannot be maintained as a center distance, isn't it? It should be a whole number. So what we will do is we will approximate it to a beautiful whole number. So what is the next beautiful whole number that we can give to a designer where he can conveniently design a gear system with a center distance of so and so? So shall I take it as 450? So approximate it to be 450 mm. 440 again, it's an absurd value. Okay, it's difficult to think of 440 mm, 4.5 mm. Very difficult. Okay, so just go for a big whole number. In case of a center distance, it's always preferred that you go for a nice whole number, 450 mm. So this is the only change in the previous problem comparatively to this problem. Now we have found out your center distance. There is no stopping you. There is no difference between the previous problem and this problem. Now once the sensor distance is calculated, all other remaining procedure would be the same. So I want you to next calculate. What do I find the next? According to the previous problem. So all of you find the diameters. So you have used this particular expression, which is D1 is equals to A to the power of 0.875 divided by 1.466, which is in equation number 12.51A, page number 223. Substitute the value of D1, which is 450 m, and give me the value of D. .02. So 143, again, diameters should be of a whole number. So shall I take it to be 150 approximately? So center distance of 450 and diameter of the worm is 150. Now, can you calculate the diameter of the worm wheel using this particular expression, which correlates center distance is equals to D1 plus D2 divided by 2. So D1 you have calculated to be 150. Now calculate the value of D2 from this. Yes, goes. It is 750 mm. So this is the value which is there in the textbook also. That's good. 750. Now, immediately, the first major step after finding the center distance and the diameters is to finding the module. Again, use the same expression there to find the module where it says that T is equal to sigma d CdV ym from equation number 12.54, page number 223. So calculate one by one. Sigma d you already know, so it is based on the worm wheel. So you would take it as 2 there. Okay. So now calculate the value of V so that you can calculate the value of CV. calculate the value of B, calculate the value of Y, calculate the value of FT, then you can calculate your module, which is this. So one by one we shall see. First calculate the value of CV. So N2, either you can use this or you can use in RPS expression, it's up to you. You want to divide by 60, you can do it, or else you can just use the small n there. Okay. So it's better to use small n. So it's just pi d2 small n2, that is equal to substitute in meters, guys. Okay, so it is 0.750 cross 0.4. What is the value of linear velocity? Point 9425. 0.9425. This is the answer what I have got. 9.42. Why there is a difference? Why there is a difference? 0.0157. Why that huge difference? What's the problem? 0.942. Okay. Now, based on this particular velocity, pick an expression to calculate the value of CV from 12.53 ABCD in the page number 223. So I have fixed upon 0.86. What is that? Okay, you have given me the value of CV. Very good. So 0.942 is the velocity. When you substitute it, you will get it as 0.86. Give me the next two digits also, Gauss. 0.8662. Very good. So that's enough. That's enough. 4 digits is more than enough. Okay. Now once you calculate CV, next go for the phase width. So phase width expression you can find down 12.64. Equation number, page number 227. So substitute the value of center distance over there and give me that value. .50 to the power of 0.875. Sorry, 875. 2 divided by 2. 104. 104.84. So it is 104.84. So what I would do is I would just approximate it to be 105 mm. 105 mm. 105 mm. Now, if B is done, FT. So FT is, again, you can see this particular equation. Be very careful, guys. In the data handbook, don't just blindly write the equation. Look into your data handbook and write. Why? Because in the worm, it would be not MT, but it would be MTE there. Okay. Nothing difference would happen. Why? Because what is MT? MT is nothing but it is MTE is nothing but MT into KL. Generally, what happens, 90% of the cases, the value of KL would not be given. That is why you would be assuming it as 1. 90% of the cases it could be done. But make sure it will not affect your calculation. But you have to show that it is MTE, not just MT there. Okay. So assume the way, since nothing has been specified, what is driving what, whether it is used to drive a sugar cane crusher or grinder or ಏನು ಅಂತ ಕೊಟ್ಟಿಲ್ಲ ಕಾರಣ. So you can directly assume it as 1 by referring the table number 12.33 to 45. Okay. Now, CS you have to take, that is for the table number 12.8 to 35. 12.8 to 35. Okay, now in this particular thing, in this table, so what he has given, the loading conditions are, first thing, it is intermittent, it is not continuous, it is clearly specified, and for the medium shocks. So for intermittent and for the medium shocks, the value could be 1.25. Pick that particular value, there, 1.25. And even you have to calculate MT, no? For that you can use the power equation, which is 2 pi N2 into MT by 60. Either you can use 2 pi small N2 into MT, not dividing it by 60, it's up to you. So what is N2? Okay, so what is the value of N2? Capital N2. $24. Okay, so 24 into alpha x. So shift to solve for x. So is this the value right? Just check. So I can take it as 11.9. Whatever the value you get, that would be in Newton meters. So I want in Newton mm. So into 10 to the power of 3 would be there, correct? 11.9436 Okay. So into 10 power 3 into 10 power 3. So 10 power 6 Newton mm. 11.936 or 94 into 10 to the power of 6 Newton mm. So whatever you get the value, that would be Newton meters. Okay. So you have to convert it to Newton mm. Is my value correct? Which I have written on the screen. Okay. MT bantu ella aitu ansutte. Now you calculate the value of FT. So substitute everything and calculate the value of FT. Okay. So this is the value of FT what I have got. 39.8 kilowatts. So I directly have written in kilowatts. 39.8 kilowatts. Okay. Now, what is stopping you to calculate module? FT is done. Next, you calculate. You have to get the form factor. So for the form factor, again, you have to go for the table number 12.28b, page number 244. Where is that? Page number 244. This particular thing you have to first work it out. Z1. Okay. So what is the velocity ratio? Based on that particular velocity ratio, whether it is single, double, triple, quadruple, what it is, based on the velocity ratio given. 25 is the velocity ratio, I guess. So again, it would be a single. So Z1 value I have taken it as 1. Now, since nothing is being specified, lead angle is not given, nor nothing related to pressure angle is given. So what we will do is, we will just assume the value of alpha to be 14.5. So just write for the I dash value greater than 20. So we have the Z1 value to be a single threaded, so it is 1. In the table number reference, you just give the reference. After that, since nothing is specified over there, what you do is you assume the alpha value to be 14.5. So these all highlighted points should be written at the end of the examination so that you can quickly revise before you go to the examination. What are the different values that you have to assume? So nothing is given in the worm whale, then assume the alpha to be 14.5. So from the table for the 14.5, what is the value of the form factor? The form factor value was 0.1. So pick that particular value, which is 0.1. Anything else? I think nothing. So this is small y, guys. While substituting in equation, no, there it is capital Y. Please do remember it. So capital Y is equals to pi times of small y. So it is pi times of 0.1. Please do remember this. Do not get confused here. So small y is Levy's form factor. Capital Y you have to substitute there, which is pi times of the Levy's form factor. So just substitute all the values and give me the module. Siddharth Shekhar. Siddharth Shekhar.
Yes, sir.
So what is the module? How much you got?
Sir, doing, sir.
Do it. Please switch on your camera and let me see your notes. Siddharth, can you please switch on your camera and show your notes, man? Module list is 16.9. So standardize this using the table number 12.22, page number 229 to give me the final module. Shekhar, I'm waiting for you. Siddharth Shekhar.
On, sir.
On. I'm not able to see you, man. I even pinned you up. Okay. Please give me your choice. Everyone should give their choice for the module. 16.9 is obtained value, but we need to standardize it. So which value should we fix upon? Give me the value. Everyone. 20? Okay. Okay. 29 now. Okay, might be a typing mistake. Okay, fine. So we shall fix upon the value as 20. So as soon as you calculate the module, immediately calculate your lead angle. Okay. So lead angle is just give me the equation number, man. I forgot to write it. Referring your data handbook. Can you give me the equation number of this? Lead angle is equals to m into z1 divided by d1, through which you calculate your lead angle. Step number 4. Siddharth, I am still waiting for you.
Sir, it's on only, sir. It's not sure.
Anyone can able to see the Siddharth's thing? Anyone?
No, sir.
So if you're able to see the Siddharth's screen,
So my voice is clear.
Voice is clear, man. Voice is no issue, but I cannot be able to see, man. I don't know what's the problem. Siddharth? Okay, what you do is immediately calculate the value of dynamic tooth load and give me the value before we do it.
Okay, sir.
Do it fast, do it. What was the equation number? 7.59. Equation number. Okay, lead angle is 7.59. fine. 7.59 degrees. Give me the equation number, man. It would be helpful for you also. I forgot, right? So immediately jump to calculate your dynamic truth load, even 12.46 page number, guys. $221. And even please give me this equation also. So it would be very much tedious for me to write all these equation numbers. I have neatly written one in this particular digital iPad. Okay. Sometimes I forget to write these equation numbers. So I keep asking you. Even give me this particular equation number, dynamic truth load equation, FS equation. 12.54 page number 223. Good. Now, so substitute all the values. I guess you know the values of sigma d, b, y, m, everything you know. Just substitute everything and give me the value of dynamic load. Siddharth, calculated dynamic load.
Yes, sir.
What is the value? What is the value of dynamic load? What is the value? How much time you take? 82.4 Siddharth into 105. 105 into shift pi into 0.1 into what is this? 20. That's it. Yeah. You should be very fast at your calculator operation. That could really help you in the examination times, because the how much fast you operate your calculator, no, you can reduce your time so much. It's very important that you get used to your calculators. Okay, be very fast at it. That is the only killing point in this subject. Seeing your data handbook, picking the equation, substituting in the calculator, getting the answer, writing. That's it. Nothing else in this subject. Okay. But the thing is, you have to be very fast so that you can have enough time in this particular subject examination, in the finals or in the interviews. Okay. 54 point in terms of kilonewton, if I write it, it is 54.36. 54.36. Okay. Shashank, SK. SK, Shashank.
Yes, sir.
Calculate the wear load. How do you calculate the wear load? Using which expression do you calculate the wear load? Calculate it.
No, sir, calculate.
Calculate the wear load. So you can use expression number 12.62a in the page number 227 there. The only unknown in this particular segment is the value of K. And you can get this load stress factor, the value of K, from the table number 12.3, page number 246. Okay. So there you'll be having two columns based on the lead angle and for the different types of materials combination. So here it is hardened steel and phosphorus bronze combination. So for the hardened steel and the phosphorus bronze combination, and for the value of gamma 7.59, what is the load stress factor? So if you get that, you'll get the value of K. So, in the data handbook, loads test. What is that table number? 12.30, 246 page number. So here it is. So for the hardened steel and phosphorus bronze combination, and lead angle is the lead angle. What's our lead angle? 7.59. So 7.59 on the sun is it comes between 0 and 10 degree. So in this particular column, this is the value. Okay, pick that particular value there. 0 point. Any difficulty in calculating the K value for the worm gas? Let me know. Okay. 0.549. Just substitute here 0.549 and give me the value of FW already given. So most of you are seeing it as 43.23. So your dynamic load is 54, but your wear load is just 43. So what's your inference? What's your conclusion? What's your inference or what's your conclusion? Good. So your dynamic load is 54, but your wear load is just 43. Okay. Not safe, not safe. So yes, so it is not safe. So previously what we are doing is, material is not safe, exactly. So previously what we are doing is, since he was not specifying the material, we used to reverse calculate the value of K and look for the other material. Since in this particular example, he has clearly specified the materials, isn't it? ಅವನಿಗೆ ಗೇರ್ ವೀಲ್ ಫಾಸ್ಫರಸ್ ಬ್ರಾನ್ಸ್ ಇಂದೇ ಆಗ್ಬೇಕು, ಮತ್ತೆ ಗೇರ್ ಸ್ಟೀಲ್ hardened steel ಇಂದಾನೆ ಆಗ್ಬೇಕು. Since he has specified the material, you cannot change the material. So what you can write is, you can write just a sentence stating that since FW is lesser than the dynamic load, material is not safe, it will wear out. So what you have to do is, you have to, while manufacturing, please improve the hardness. That statement you have to write. So when we, as you being a design engineer, if you write that particular statement into your design sheet, so he will understand that the material is not safe for the wear. What he will do, he will increase the hardness, he will increase the BHN by machining it with a lot of other techniques. Okay, so just write this particular statement. Since the material of the worm and the worm wheel are already specified, we must try to improve the BHN value while machining. Just write it and leave that. Okay, you cannot change the material. Just because we cannot change the material, you can. There is no BHN value also for the worm gap. In case of a spur and helical gap, we used to increase the BHN. BHN was nearly specified in the columns, no? Driver genu, pinion genu, gear genu, BHN value neat specify ಮಾಡ್ತಾ ಇದ್ರು. We used to calculate the new BHN value, upgraded BHN value, and we used to write. Since nothing is given in that particular table, you can just write this sentence and leave the problem there. Okay? Understood? Since material of the worm and the worm wheel is already specified, you must try to improve the value of BHN while machining. So while you are manufacturing this particular gear, the surface of these particular gear tooth has to be machined so that it would be hardened. So once it is hardened, wear will not happen. Its surface hardness would increase, BHN would increase. So that you have to do. Okay, literally, while you are in the industry, you'll come to know the importance of all this. Okay, in the design catalog, you will write these particular statements. So once you write the statements, the manufacturer will see that particular catalog, and whatever the different statements you have written, based on that, he will manufacture a part. That's beautiful about the mechanical engineering. Okay, beautiful thing. Okay. Next, shall we calculate the efficiency? To move on to calculate the efficiency next, shall we? So again, you can use the same old expression which you have used in the previous problem where the worm drives the worm gear. I told you 90% of the cases, worm will driving the worm gear. Okay, so you can use this particular equation 12.57c from page number 225 to calculate efficiency, how efficient your worm gear system is. So for that, you require the value of theta and mu one by one. We will calculate now one by one. Okay. First, calculate theta using this particular expression in 12.56d, page number 224. Okay. You can calculate the theta directly there. 14.37 is the value of theta. Okay, so let us take that. So next you immediately go on mu. On which particular velocity does the value of mu depend? Already we have solved in the previous problem. On which particular velocity the value of mu depends. On which parameter the coefficient of friction depends. What is that mu parameter that you have to calculate in order to know the value of mu? So now you have to calculate the value of mu, no? So which parameter you must have to calculate for that? Anyone? We are the rubbing velocity. So just write mu depends on the rubbing velocity. And we calculate the rubbing velocity using the expression 12.60b to 26, page number. Substitute everything. So give me the value of rubbing velocity. Shift the pi into 150 into 10 divided by 1000 into cos of 7.59, and make sure your calculator is in degrees, not in radians, guys. So it would be a blunder if you keep your calculator in the radians and do the calculations. Okay. 4.75 is the value I have got. Is that the value correct? Is the value correct? No. So VR is known. You must find the expression to calculate the value of mu. So expression to calculate the value of mu can be picked up. There are, I think, 3 to 4 expressions there. In order to pick that particular expression, you require the value of V. You have already calculated it, but once again you calculate. I have just the value, I'll just substitute there. It is 4.71 meters per second. So for this particular velocity, can you give me the expression to calculate the value of mu? If you specify the equation number, that is more than enough for me. So for this velocity, what is the expression through which I can calculate the value of mu based on rubbing velocity? Take a proper equation there. .6, page number 226, exactly correct. So pick that particular equation. So where it says mu is equals to 0.025 plus 3.281 VR. So VR is this divided by 1000. So just substitute the value of VR, whatever you have got. So, and give me the value of mu. So mu is how much? Srinidhi? Very good. Ivan? Ivan D'Souza.
Yes, sir.
Give me the value of mu.
Sir, I'm getting same, sir,
Can I
0.04.
Can I have few more digits, Arvind? 0.04, fine. Few more digits, it would be better. Because 0.5.
Okay.
Fine. So now the value of theta is calculated, the value of mu is calculated, substitute entire thing in that big equation and give me the efficiency. Gagan? Efficiency 75.7%. So if you calculate it, it would be around 0.757, something like this. Okay, when you multiply it by 100, it would be 75.7. Okay, so guys, we will end here. All of you mark your attendance in the attendance sheet. And my counseling batch, whoever are there, my counseling batch has to stay in the class. Others can leave the meeting. So once you have marked your attendance in the